So as we discussed in the previous video, this is a simple hello world program using MPI. So first I have installed MPI into my system, and then I have written this program with MPI in it and com size, rank and everything, and then I have printed that this is the rank out of these many processes, and then I have ended the MPI protocol here. Now after this I close this, and what I do is I just simply compile this using MPICC. You cannot use GCC. As you can see here, we got a fatal error when we tried to use GCC. So if we are using MPI, we have to use MPICC. So now we compile it and then we run it, and here we can see that hello world, I have ranked this out of this. So this was the simple hello world program in using MPI. So now we'll be just simply starting with the rest of the content of our syllabus. So the hello world has been written in C programming language, hence the 3-line preamble should be commented and replaced by the int main and all that. So we did that, we have seen that. Then this it has also to be compiled only once to be executed on all active processes. Such a methodology could simplify the development of parallel programs. So we can also run the program using MPI execute. So let's try it and run the program using MPI exec, and let's try it. So we have this here, so we'll try MPI. Wait, I'll just move to the particular function, directory. So yeah, this is where we are. Then we'll try MPI exec n3 msmpi hello. Wait, mine one is hello. So yeah, so this will be where that particular is to be located. So we'll just directly use hello world here, and it is showing that there is no such directory. So yeah, so we ran this for all the 3 processes. So hello world, I have ranked 0 out of 3 processes, and then 2 and then 1. The simple output is there. So after this execution, we can see that this is how we can execute our MPI programs. So this is one thing. Then after, so this is just how to execute the program. Now we can use our so hash include stdafx is basically needed because the MS Visual Studio compiler has been used. So, and standard input output is needed for printf, and then MPI is also used for the MPI program itself. So the MPI program, including definitions of variables, will be executed in all active processes. The number of processes will be determined by parameter n. So we used 3 there, so that's why 3 processes were there. Of the MPI execution utility MPI exec, usually provided by the MPI library implementation. Now the MPI init initializes the MPI execution environment, and MPI finalize exits the MPI. MPI com size can returns the size, as I have already told, and rank returns the rank, and so and so. So if we want to run this in Fortran, we'll have to use this, but we are not going to run in Fortran. Then types of point-to-point operations. MPI point-to-point operations typically involve message passing between two and only two different MPI tasks. One task is performing a send operation and the other task is performing a match and receive operation. The term point-to-point communication is used to describe a communication between one source with one destination. So there are different types of send and receive routines used for different purposes. Synchronous, then we have blocking send, blocking receive, then non-blocking send, non-blocking receive, then we have buffered send, combined send receive, and ready send. So then we come to buffering. So consider some one case that a send operation occurs 5 seconds before the receive is ready. So where is this message? So this was also done in computer networks, that the if the message is reached to the receiver earlier than it is ready to receive it, then it can be stored in buffer. And similarly, if the message is ready, the message is ready in the sender side, but the what was it, the if the similar thing happens at the sender side, then there also a buffer is there for it to be stored. Now MPI implementation decides what happens to the data in these types of cases. Typically a system buffer area is reserved to hold data in transit. So here also we have the same system buffer, same concept of system buffer. This buffer is not same, but the concept is same here. So if one or the other is slow, or something like that is there, some restriction is there, that even only after this operation is done, then only the second operation will be performed. So like suppose two packets are being sent, and the first one has not been received yet and the second one has been received, so the second one will stay in buffer if those packets are to be in the order. So system buffer is really necessary. So MPI send and receive calls operate in the following manner. First, a process decides a message that needs to be sent to another process. Then suppose there are two processes, A and B. So if A decides a message needs to be sent to B, A then packs up all of its necessary data into a buffer for B. After the data is packed into a buffer, the communication device, which is a network, is responsible for routing the message to the proper location. So that network is responsible to make the message reach the particular destination. The location of the message is defined by the process's rank. Then we come to blocking and non-blocking functions in the next video. Thank you so much for watching.